This is a summary of combining all the transformations for functions. It doesn't matter what type of functions you have, you always could transform from the parent function or from given function. So there are only 4 parameters you need to know what it will affect the graph. So if we write it in general function notation, you have a function f, this is function's name, then k bracket x minus p plus q. So a, k, p, q will control how the graph will change and the position of the graph will move. So for the a value, it is a vertical stretch of the whole graph. So vertical stretch. It will affect the steepness of the graph. So you could write it as vertical stretched by a factor of a. And all of them is from the parent function, the given function y equals f at x. So once based on this parent function, then all the other functions in that family, you could apply the same rule transformations to graph it. So you know AKPQ, you could apply it to any functions. So in the description, always we use a positive number. The reason for that is positive number, they are measurable numbers. So if a is less than 0, then the whole graph will be reflected in the x-axis. And the a value actually is changing the slope of the graph. So before the slope is m, now the slope is m times a. So the y value is just, in other words, it's just change the rise. So the change to the graph is the x value won't change, but the y coordinate times by a value. So this is a parameter a, how it will affect the graph, and for the k, it is a horizontal stretched, vertically stretched, horizontally stretched. By a factor of 1 over k. So here, remember, we use absolute value, positive sign, and also if k less than 0, the whole graph will reflect it in the y-axis. And if it's hard for you to remember its divide, you could think k bracket x minus p equals x0. This is a parent function's x coordinate. You solve for the new k x value, you move the k to other side. It's x original k, x value divided by k. Then you continue solve for x, you move the minus p to other side. Its opposite is plus p. So the new x coordinate is x original one divided by k plus p. So this is for this one, the y value won't change. It's a times y, and x is divided by k. So this one is how the a and the k will affect the graph of the parent function. And the pq value is plus p. It means is the new x coordinate is left right, move it. If p less than 0 is left p units. And we use absolute value sign again, use positive number only, and if p greater than 0, then the whole graph is more to the right, p units. And for the q, you can think this f at k bracket x minus p bracket, you could think is a f bracket, before is x0, then plus q. And this one is y value, so the new, this is y0, original y coordinate. So now it becomes new y. So it's y equals a times y0 plus q. So this is a new y coordinate. So now is q is less than 0, the whole y value is minus q, so it's down q units. And again, use absolute value sign is measurable stuff, and if q is greater than 0, then it will be up. The y value is added, so the y coordinate will be greater, is up, q units. So here there are two important things, is the new x coordinate is original x coordinate for the parent function divided by k plus p, and for the y, it's just a times original y coordinate then plus q. So you don't have to remember these two, it's just the whole thing equals x sub 0, then together this is y0, then you will solve for x and y. You will have y equals a y0 plus q, this one x0, solve for kx, you have x0 divided by k plus p. So these are the two xy coordinates for the new graph. So important thing is you need to know how to graph the parent functions. The parent function, you have y0 equals f at x0. So these are the xy coordinates on the parent function. So you know how all the AYPQ works, then you know how to graph all functions. Plus you need to know how to graph the parent function. Then you just move the points to the new x comma y, then you have the new graph. So now we are going to see if we combine all this one using words. So this is transformations are performed in the following order: stretch, reflection, this one means A and K, and transformation is P and Q. And how to remember it is bad math. So multiplying, dividing first, adding, subtracting after. So you have x is is x over k. So x over k plus p. So we do the division first, and y is a times y plus q. So that's the reason we do the multiplication division first, then pq after. So here is just repeat what I described above. Okay, transformation for a value is vertical stretch. If a less than 0, then reflect. The point on the graph is x comma ay. And the horizontal stretch, if no a pq, you only have k is just over k, y value don't change. And if you only have q, then just y plus q. If you only have p, then it's x plus p. And if you put everything together, then it's x over k plus p, ay plus q. So each time, what you need to do is find the x0, y0 for the parent function, Then from the parent function, the new y is a times y0 plus q. New x is x0 or k plus p. So we are going to practice on the next page. So a function f at x, the parent function is square root x, then it asks you to graph g at x. That is a transformation from the parent function square root x. First thing, it asks you to write it in xy notation. So this one, function g at x, function f at negative 2x minus 2, we call them function notation. And write it as a xy notation means we replace this function f name with a square root x. So we are going to rewrite it. So this part, whatever after the function's name, this part is a input. So what we are going to do is replace a x with this input. So function f bracket, this input we sub in for x, then we are going to have just replace x with the input, negative 2 bracket x minus 2. Then negative 3 times it, we just continue to write it in. So we replace g at x with y, then negative 3 function f at this one, replace it with square root. So square root, negative 2 bracket x minus 2 bracket. This is a function f at this input, then offset is plus 3. So this is also negative 3 y0 plus 3. So now we are going to fill in the chart. This one is going to be the original function x coordinate and the original y coordinate for parent function. So it just equals square root x, the original input. So for this one, square root, we know it won't have any negative number for x. Square root negative, it doesn't work, doesn't exist. So we start from 0, then 1. We could use 2, but square root 2 doesn't have a nice number, so we want to have a nice number. We use a perfect square number. So 1, 4, 9, and 16. So we use all the squared perfect square numbers. So square root 0 give you 0, square root 1 is 1, square root 4 is 2, square root 9 is 3, square root 16 is 4. Then it's easier to find those points on the grid given. So that's the reason we pick those points. And after that will be x0, square root x0, and for the y value is, we are going to rewrite it as y equals negative 3, then f at x0, then plus 3. So this is when we have the negative 2 bracket x minus 2 equals this one, then what the y value will be. So it will be f at x0 is your y0, so it will be negative 3 y0 plus 3. So it is a times y0 plus q. And sub in, we have negative 3, a is negative 3, y0, q is 3. So this is a, this is k, this is p, this is q. So it's a times y0 plus q. Then we sub in negative 3 times y0 is 0, then plus 3 give you 3. The next one, negative 3 times original y value is 1, then plus 3 give you 0. So continue to do the calculation. We have negative 3 then negative 6, negative 3 times 4 plus 3 is negative 9. Then we want to find the x value. X value is negative 2 bracket x minus 2. This is your input equals the original parent function's original x value. So we solve for this x, it will be x0 divided by k plus p give you x0 divided by negative 2. That is your k value. P value is 2 plus 2. Then we sub in, we have 2. This negative 1 over 2 plus 2 give you 3 over 2. 4 times negative 2, 4 divided by negative 2 plus 2 give you 0. 9 divided by negative 2 plus 2 give you negative 2.5. Then 16 divided by negative 2 is negative 8 plus 2 give you negative 6. Then we have those points. So first point is 2, 3. So we are going to just go it 1, 2, 3, 4. 1, 2, 3, 4. Then negative 1, negative 2, negative 3, negative 4, negative 1, negative 2, so 0. Then 2, 3, 2, 3. So this is 1 point. 3 over 2 is 1.50. Then 0, negative 3. So this one 0, negative 3, and negative 2.5, negative 6 will be somewhere here. Then we are going to connect those points. Negative 6, negative 9 will be somewhere here. So connect them. Then we are going to have, and we need to make sure that this is a starting point. This is our starting point. It will all the way go this way. The reason for that is a parent function. This is a 0, then this way. So this is starting point, then it won't pass this point. The reason for that is if x greater than 2, you will have a square root negative 2, so it's not allowed. So this is your transformed function. So the domain is from negative minus minimum of x to the maximum of x. So minimum is the left side of the graph is negative infinity for x horizontal x value, and for the maximum is the maximum value for the x, so it's 2. So if we write the domain in set notation is x belongs all real numbers such that from negative infinity to positive 2, and negative infinity you are not going to reach it, so we don't put equal sign here. And for the positive 2 is a ending point, is no open dot, so it's include that point, so it's less than or equal to 2. For the range, we find the y value, the minimum is negative infinity, and the maximum is positive 3. So this is for y. So range is a valid y value, y in output. So from negative infinity to positive 3, and put y in between. Infinity we couldn't reach it, so no equal sign. And for the 3, there's no open dot. Include 3 is less than or equal to 3. The x-intercept is y value equals 0 is 3 over 2. And 0 for y. Intercept is x equals 0, y equals negative 3. So y-intercept, subbing x equals 0, find the y value for x-intercept is y equals 0, then the x value. Intervals of increasing from left to right, If the graph is going up, that is increasing. Or you could think the slope is positive, then it is increasing. So this will be all the domain. So from negative infinity to 2, the graph is increasing. So intervals of increasing or decreasing is regarding the x. What's the range of x give you the increasing, and the decreasing is from left to right is going down. There's no area of going down, so it's none. And this is done. So for this question, this is how you could graph it by creating the table values. So how to use the table values is we create the parent function. So x0, y0. We create the parent function x0, y0, and after that, we let negative 2 x minus 2 equals 0 to solve for the x. Then you will have a formula for the new x value. And for the y, we just sub in the f at 0 is y0, so negative 3, 0 plus 3 is your new y value. So that is how you are going to have the x0 over k plus p for your new x coordinate, ay0 plus q for your new y coordinate. And this method works for all function transformations. Now we are going to just change the parent function from square root to absolute value function, and all the AKPQ will stay same, and we are going to see how what changed. And also I would like to say this starting point is 2, 3. So before is 0, 0, now is PQ. So each time if you have a starting point 0, 0, then after the transformation it will become PQ. So this is the next question, absolute value. So we are going to rewrite g at x in xy notation. So this function input negative 2 x minus 2, we are going to put it in the input. So we are going to have g at x, we write it as y, they are interchangeable. So we have negative 3, then function notation part, we put the input to x. So negative 2 bracket, x minus 2 bracket, the absolute value. This is function f at input, then plus 3. And from this general form, we are able to write a, k, p, q out. So a is a number at front of this function notation, and k is a number at front of the x, and p is if it's in factor form, the p is after the x. You solve for x, move the negative 2 to other side, it's positive 2, so it's opposite. And q is a number outside of this function notation, is 3. So fill in this chart the x0 function original y coordinate for the parent function. So x0, this absolute value, we don't have any restrictions, so we are going to pick the number around the 0. So x will be the negative 2, negative 1, 0, positive 1, positive 2. And the absolute value of negative 2 is just a distance from negative 2 to the origin, so it's positive 2. Absolute value is just that point, the distance from that point to the origin. So negative 1 to 0 distance is 1. Then 1 to 0 is 1, 2 to 0 is 2. So this is a parent function's original xy coordinate. Then after that, we are going to write it as the y value is -3, then function original x 0, then +3. So it's same as -3y, original y coordinate, then +3. So this is ay plus q. So we sub in -3 times 2 plus 3 will give you -3. Then -3 times 1 plus 3 is 0. -3 times 0 plus 3 give you 3. Then -3 times 1 plus 3 give you the 0 again. Then -3 times 2 plus 3 is -3. For the new x coordinate, we solve for the x0 equals -2 bracket x minus 2. Then you move the k to other side, then move the p to other side. You will have x0 over k divided by k, then plus p. So we sub in the k and p, and you will have divided by -2 plus 2. So -2 divided by -2 plus 2 give you 3. Then -1 divided by -2 plus 2 is 2.5. 0 divided by -2 plus 2 is 2. So we have 1.5 and 1. Then we are going to find those points. The first point is 3, comma, -3. The new x and y. The next one is 2.50. So 3, -3. Then the next one is 2.50, 2, 3. 1.50 and 1, -3. Then use a straight line to connect them. You will have 2 branches, okay? And this point is your PQ. So as long as if you have the original point is 0, 0, it will become P and Q. Because AY plus QY is 0, you will have Q, and X divided by K plus P, 0 divided by K is 0 plus P, so 0, 0 will become PQ. So that is this point, and after that we are going to determine domain and range. And for this one, the minimum for the X is the very left of this graph is -infinity, and this one keeps going right, so it will be positive infinity for the horizontal x coordinate. So it will be from -infinity to positive infinity is all real numbers. For the range, for the y value, the keeps going down, the minimum is -infinity, and it has a maximum as 3. So you will have the minimum is -infinity, maximum is 3. So y is between the minimum and the maximum. So for the x-intercept is y equals 0. We have 2.5 and 1.5. We have two x-intercepts. And for the y-intercept is x equals 0. If you don't have it, we sub in to find the y value. So y equals -3, -2 bracket, 0 minus 2 bracket, plus 3. So we are going to do the bracket first. So it's -3. Then -2 times -2 give you +4, then plus 3. absolute value for 4 is positive 4, so we have negative 3 times 4 plus 3. So we need to drop the absolute value. If it's negative number inside absolute value, we are going to change it to positive because it's distance. Then we have negative 12 plus 3 give you negative 3. So the y-intercept is 0, negative 9. And the intervals of increasing is from left to right going up is increasing. So the slope need to be positive. And from this graph, it's from negative 3 to 2. So it's from negative 3 to 2. Increasing, decreasing intervals is for the x value. So decreasing is from left to right, is going down, and is negative slope. So it's from 3 to positive infinity. Okay. So this is one way to graph by creating a table of values. Or another way you can graph it is just draw the parent function using the x0, y0. Then after that, you do the y value. For example, this 1, 1, the y value times negative 3 becomes negative 3, and the x value divided by negative 2 is negative 1 over 2. So it will be here. That is after stretch. And other point, 0, 0 will stay same. So this is your new graph. And after that, you just move the PQ. So P is positive 2, Q is 3. So you just move the point right 2 up 3, then right 2 up 3. Then you will have the new graph. So this is two ways to do it. One is create table values. Another one is a times y x divided by k from the parent function. So this is y equals negative 3, negative 2x. Then after that, move those key points using the PQ. So it's right 2 up 3. Then you can graph the new graph after transformed. So this is for these two functions, and we could practice more. So the next one is given you the xy, this is not in terms of the function f of x. We want to rewrite it in the function notation. The reason for that is it's easier for you to find the AKPQ. So g at x equals negative 3 square root this one. So this is your input for function f at x. So we are going to write negative 3. We replace the square root with the function's name. This is your square root. And the input is negative 2x minus 4 plus 5. And remember that we need to have the factor form. So we take the negative 2 out. Even if negative 2 is not common factor, you still need to take it out. In the bracket, we have 1x here. Negative 4 divided by negative 2 is divisible, so it's an integer. Otherwise, you could have a fraction here. Then plus 5. So we have the a is negative 3. K is negative 2. P is opposite, negative 2. Q is 5. So it's kind of, we have this is y0, so we have negative 3 y0 plus 5. And for the x, we solve it. Negative 2 bracket x plus 2 equals x0. So we solve it, you will have x0 divided by negative 2, then move the plus 2 to other side is minus 2. So this is how we create the table values. And also because we have the AKPQ, we could put them in these transformations descriptions. So the graph of this one is the parent function, the square root x. If you see square root, the variable is under square root, then the parent function will be the simplest form for the square root family. So it is square root x. And this one means your AK equals 1. No stretch, and the PQ are 0. So you just change this 1, 1, 0, 0, you will have just the square root x left. So it's vertically stretched by a factor of the a value, so absolute, the positive number. If negative, it will be reflected in the x-axis. So reflected. Then horizontally stretched by a factor of, we do the division of k, so it's 1 over k. And if negative, it will be reflected in the y-axis. And translated, the p-value is negative, so it's left. And positive to the q-value is 5. We just use a positive 5 here, and it's up. After that, we are going to draw the parent function. So it's y0, the parent function is square root x0. So for the square root x, we know the x couldn't be negative, so we start from 0. And perfect square number to get a nice number for square root. So we have 1, square root 1 is 1. 2, 3, we don't want to have it because not perfect square number. So 4, square root 4 gives us 2. And for the x0, another number we want to take is 9. You could use other numbers, but it's hard to graph. So square root 2 give you 1.4, square root 3 give you 1.7. They are not on the grid, so that's the reason we want to take the perfect square number. So next 9, number is 9, square root 9 give you 3. Next number 16, square root 16 give you 4. So they are the numbers on the grid. And after that, we just a value times 0 plus 5. So negative 3 times 0 plus 5 is 5. And 2, negative 1, negative 4, negative 7. And this one is x0 divided by negative 2 minus 2. So 0 give you negative 2. So this is PQ. And this one, negative 2.5. 4 divided by negative 2 minus 2 give you negative 4. 7, negative 6.5. 16, 7, negative 10. So they are the 5 points. Then we are going to find those points on the graph. Then 0, 0 becomes the PQ, negative 2 and 5. This is your starting point. And negative 2.5 is 2. Negative 4 is negative 1. Negative 6.5 is negative 4. Then this is connect them, you have this graph. So this is your ZX. And the domain will be the minimum for x to the maximum of x is negative 2. So x belongs all real numbers. It's from negative infinity minimum to maximum, x in between, less than or equal to. And for the range, so we need to This is for g at x. X belongs all real numbers. Negative infinity x less than negative 2. And for the range for y will be y belongs all real numbers. The minimum for y is negative infinity and the maximum for y is 5. And for the parent function, if we graph it, you will see it will be 0, 0, then 1, 1, 4, 2. So this is your parent function f at x equals square root x. And from here, we could see that the maximum for x is, the minimum for x is from 0, and the maximum for x is infinity, pausing infinity. And the 0 is included. For the range, it's same thing. Y belongs all real numbers. Minimum is 0 for y. Maximum for y is infinity, positive, and y in between, less than equal to, less than. So this is for the square root function after transformations. And the next one is a piecewise function. So you don't have one equation for this one. And what we are going to graph is we pick those ending points. So we have this point is negative 6, negative 1, and this point is negative 3, positive 1. This point is 3, negative 3. This point is 9 and 1. So based on move these 4 points around, you will have a new graph. So I will copy this one to the parent function. This is f at 0, y 0. So first point, negative 6, negative 1, negative 3, positive 1. And next point is 3, negative 3, y. Last point is 9, 1. So we are going to see this time we are not able to write it in the xy notation, but we could rewrite it as factored negative 3 out. Then x 6 divided by negative 3 give you negative 2. By doing this, you are able to find the AKPQ. So A is 2, K is negative 3, and P is opposite with a number inside the bracket is positive 2, and Q is negative 1 outside of this function notation. So vertical stretch is your A value is 2 and no reflected because it's positive. Horizontal stretch by a factor of, we solve for x, we move negative 3 to other side, is division. So we use positive number to describe the transformations. So negative means reflected in the horizontal direction is y-axis. And so from one side to another side of the y-axis. So translated, P is positive is right. So 2 units right and 1 unit negative is down. So this is a transformation. Then we are going to see this one is a y0 plus q. So a is 2, so 2 times y0 minus 1. This is x over k plus p. So for this one is x divided by negative 3, then plus 2. So we are going to do the calculation for the new y coordinate. 2 times negative 1, sub in the original y coordinate, then minus 1 give you negative 3. 1 times 2 minus 1 is 1, negative 3 times 2 minus 1 is negative 7. 2 times 1 minus 1 is 1. Then for the x, negative 6 divided by negative 3 plus 2 give you 4. Negative 3 divided by negative 3 plus 2 is 3. 3 divided by negative 3 plus 2 is positive 1. 9 divided by negative 3 plus 2 give you negative 1. So we have 4 new points. So we are going to find those new points on the graph given. So 4, negative 3 is your first point. And next point is 3, 1. So this is a 1 line segment, and 1, negative 7. And negative 1, positive 1. It's done. So this is after transformation, the new graph. So it is ZX. And for the parent function, the domain is from the minimum to maximum, the very left to the very right. For the parent function is from negative 6 to 9. So the domain will be x, because continuous line, so x belongs all real numbers. Then minimum, maximum, put x in between, no open dots will be included, so it's less than or equal to. For the range, we find the minimum, maximum for y. Minimum for y for the original one is negative 3. The maximum for y is positive 1. So minimum, maximum for y, put y in between, no open dots, means less than or equal to. For the g at x, the very left to very right of the graph is from negative 1 to positive 3, positive 4. So it will be x belongs all real numbers such that negative 1, minimum, maximum, then put x in between, no open dots, less than or equal to. For the y, it belongs all real numbers. Minimum is negative 7, maximum is 1. Then put y in between minimum, maximum, less than or equal to, no open dots. So always minimum, maximum. For domain is x, range is y. Alphabetical order, x first, y second. X is domain, y is r. D is first, r is alphabetical order after D. So x is alphabetical order before the y. And in this lesson, we have go over the AKPQ. They are controlling how a graph will be transformed. And in this lesson, we showed one method is creating the table of values. So the new xy is ay0 plus q, x0 divided by k plus p. Put the parent function, the x0, y0 here, and do the calculation. You have the new graph. Thanks for watching.